Well, here's practice problem number 1, calculating information about an object moving in a circle. So we know a few things about the problem. The problem reads, a 1,650 kilogram car, which is the mass of the car, I'm going to go ahead and write down my given information just in this space here, is traveling along a circular path as pictured here. The radius of the track is 225 meters, and a car completes one lap around the track in every 37.7 seconds. And this is capital T because this is specifically the period, which by definition is the time it takes to go around a circle once. Part A says to draw and label the velocity, acceleration, and force vectors of the car. Well, the velocity vector is always drawn in the direction the object is moving. In this case, this object is moving in this direction here. And this velocity is specifically called the tangential velocity because the velocity is tangent to the circle. The acceleration of an object moving in a circle is always towards the center. That is because the force causing the object to move in a circle is what's called the centripetal force, and those are always in the same, force and acceleration are always in the same direction. The force causing an object to move in a circle is always towards the center. Therefore, this is the centripetal force always points towards the center. So question B, calculate the speed of the car. Well, the speed of the car that's moving in a circle is called the tangential velocity. Now this is not the period of the velocity. I know that's two T's and that can get confusing, but this is specifically the tangential velocity. The equation for velocity, especially constant speed more specifically, is distance divided by time. Well, distance around a circle is simply the circumference, which is 2 pi r. So it's still distance, divided by time, which in our case is the period, the time it takes to go around once. For this problem, we have 2 pi times the radius, which is 225, divided by the period, which is 37.7 seconds. To put that in the calculator, we take 2 times pi times 225 divided by 37.7. which gives us an answer of 37.50 meters per second. This rounding, just to refresh your memory, we always round to 2 decimal places. So I go to the third number to see if it makes the second number round up, which that 9 makes this second 9 round up, which then in turn makes that 4 round to a 5, which gives me this answer here. Part C is asking for the centripetal acceleration. To calculate centripetal acceleration, my equation is the tangential velocity squared divided by the radius. Many people forget the square, similar with our kinematics. That's an issue that some of you ran into. So please remember to don't forget the square. So we have this number here, which is our tangential velocity, which is what we found earlier, 37.5 squared divided by the radius, which is 225. And normally for these problems, I don't round until the very end, so I just keep my number going in my calculator. So I square that answer, which is my velocity, divided by the radius. So I get an acceleration of 6.25 meters per second squared. That is the acceleration. Last part of the problem asked me to calculate the centripetal force, or the net force. The net force acting on the object, which in this case is the centripetal force. That's what's causing it to go in a circle. I take the mass times the centripetal acceleration, which in this case my mass is 1,650, times my acceleration, which is 6.25, and that will give me a force. So multiply my acceleration that I found in the previous problem times 1650, which gives me a net force of 10,312.01